cheatgrass has actually come up a couple times already today, and much as I hate it, we work on it a lot. And so I'm going to just go ahead and let Cara talk to you about her project that she's working on. So Cara Noseworthy got her bachelor's in rangeland ecology and watershed management at the University of Wyoming. She's working on her master's degree now, and I think she's kind of bitten off a very large chunk to try to chew. So I'm going to let her tell you guys about it. So let's welcome Cara.
Okay. All right, thanks, Brian. So I want to talk to you guys today about a rapid assessment protocol for assessing cheatgrass infestations in Wyoming. And Brian and I developed this protocol. As he mentioned, it's for data collection for my master's project. So I'll talk a little bit about cheatgrass. If you're familiar with it already, you can tune that part out. But for anybody who's not familiar with it, I'll talk about what it is and why it's a problem. I'll go through my project a little bit, the objectives and methods, and that'll really just serve as some context for the assessment protocol. And that'll be the real meat of the presentation. So if you take anything away, that's the part you don't want to miss. Cheatgrass, or Bromus tectorum, became widespread and dominant in western North America by the early 1900s. It's very prevalent in the western United States and very much present here in Wyoming. It's an exotic winter annual, and that basically means it germinates in the fall, overwinters, and then continues growth rapidly in the spring. It favors disturbance, but it doesn't need disturbance to invade an area. So in other words, just because cheatgrass shows up, it doesn't necessarily mean that bad management practices were in place, such as overgrazing. And it's a problem on our rangelands for a number of reasons. It tends to outcompete and displace our native perennial grasses, and it promotes fire. So it's an annual, there's a lot of fuel built up. It's usually real easy for a fire to spark once it dries out, and that can reduce sagebrush, which is bad news for any wildlife that are dependent upon sagebrush for food or cover. In turn, cheatgrass is really good at taking advantage of the open spaces and excess nitrogen left behind by fire. And so it kind of enters into this nasty cycle where cheatgrass promotes fire and fire promotes cheatgrass. It's considered an unreliable forage, so it can be good early spring forage, but there's a really short window in which to graze it. And then once it matures and dries out, the seed heads can be damaging to livestock, causing things such as lumpjaw. So that's just kind of a brief overview, as I said, for anybody who's unfamiliar with it. How we approach it is pretty much on a case-by-case basis. So there's a lot of land in Wyoming run by different agencies or managed by different agencies. And so it pops up in an area, and the agency in charge of that area takes care of it or doesn't take care of it, depending on resources like funding and time. There are some more organized efforts taking shape. So there's a couple different groups in Wyoming that come together solely for the purpose of discussing the issue of cheatgrass. And the Cheatgrass Task Force is one of them. They've started meeting this last fall after a long break. And basically it's just people from different agencies across the state coming together to talk about successes and failures with cheatgrass management and what's going on in their area. And this brings me to the question then of, are isolated efforts effective, or should this problem maybe be approached on a larger scale? And I bring this up because this question is really the basis for my project, this idea of maybe looking at cheatgrass on a statewide level and coordinating efforts. And so there are already some examples of large-scale efforts. The Great Basin Restoration Initiative, the idea there was to bring together state and federal land managers and scientists, agree on the issues facing the Great Basin and how to approach those issues. And it's the same story with the Restore New Mexico initiative, kind of looking at restoring on a statewide level and bringing groups together to do that. So my project, in a nutshell, is looking at the statewide prioritization of cheatgrass infestations in Wyoming. And there are two main objectives. The first is to develop a data set that provides a better picture of the distribution of cheatgrass in Wyoming beyond presence absence. So to my knowledge, there's currently no map that really shows or gives you a good idea of this for the state. And also a data set that's useful in developing a distribution prediction model. So when I say beyond presence absence, for my project I've been focusing on 5 different categories based on percent cover, which are up there in the colored circles. And the second objective then is to use that data set to develop a model for prioritizing infestation statewide based on invasion hotspots, which would be where our distribution prediction model would come in, and then overlap with critical wildlife habitat or other areas that might be important for management. This is a quick rundown of the methods that we're using to achieve those objectives. So collecting and analyzing data from agencies on distributions. There's a lot of people out there every summer from different agencies collecting data, carrying around a GPS. A lot of you are probably those people who are out there all summer. So the first objective was to kind of gather as much of that data as we could. The problem with that is that usually the data comes in a lot of different forms, and it's a lot of the times just presence-absence data. But it's still useful information, and we did get people contributing. I should mention that this project started last fall. So we began collecting data probably towards the end of the fall and spring. Host workshops to gather local expert knowledge. The idea here was to sort of tap into a different body of information for anybody who's out there all summer, maybe not carrying around a GPS, but who has a good idea of what's out there. Create a survey design for the state and conduct field surveys. And that's where the assessment protocol comes in, which again, I'll go into much more detail here in a bit. Fill in any gaps. That really comes into play with the second summer of data collection. And then develop our model, our prediction model for distribution, and bring that together, look at overlap with other data sets to come up with our final prioritization model. And I'll go into some of these in a little more detail. For gathering local expert knowledge, as I mentioned, we hosted workshops last spring, and we pretty much handed out BLM maps and had people draw polygons where they knew cheatgrass was located. And we had it color-coded, again, depending on percent cover. And it was pretty interesting to see the different scales that people, I guess, decided to draw at. So some people just covered the entire map. Though Wyoming is apparently just one giant cheatgrass infestation, which is not totally unbelievable. And then we also had producers at some of these workshops who were able to get really detailed with their properties. So again, that was just kind of interesting to see. Once we had all of the polygons, we digitized them. And I think there's just one map missing from the image up here for Casper. But again, kind of interesting to look at. Some people were on a much coarser scale than others. And so I think it'll be interesting to look at the question of how local expert knowledge compares to what's actually out there. But in addition, I think this data set will be really useful for targeting areas for surveying this next summer, and also for if we're able to validate some of this data, using it to gauge the performance of our distribution prediction model. Create a survey design for the state. The objectives for this last summer, which again was our first summer of data collection, were pretty broad. So it was basically to get adequate representation of the states and get as much coverage as possible. We did run an analysis to get some points they mostly served as guidelines. And we excluded areas above 10,000 feet, mostly because cheatgrass can grow at high elevations, or they're finding it at higher elevations, but it's typically not as prevalent up there. And croplands in urban areas weren't excluded from the analysis, but they had a lower probability of receiving a point. So the 200 yellow points up there were used as guidelines. And I say guidelines because a lot of the times we couldn't make it to the actual location of the point, whether it was because it was on private land or time constraints, or because we were lost in northern Sweetwater County and didn't want to be out there all night. which, yeah. Anyway, so the objectives for the data from this summer were to be able to use it to validate some of our current data sets if there was any overlap. And we haven't done much of that, but mostly to start developing our predictive model and determine where to survey next summer. And that brings me to what we were actually doing out there at the points to survey. And so the Cheatgrass Rapid Assessment Protocol, again, something Brian and I put together for the purpose of just being quick so that we could get as much coverage as possible. So it involves taking a picture, marking a point with a GPS, and then recording percent cover of natives, shrubs, bare ground, and cheatgrass based on the 5 categories in the red box. Marking down the size of the infestation, and then just making a few other notes, such as the dominant shrub in the area, if there's other invasive annual grasses, and any evidence of disturbance. So really quick, and you're probably all wondering, well, if this is the meat of the presentation and you just explain the whole thing, then how is that possible? But it's possible because going back to Rachel's presentation, sort of, it is available as an app or as a form for the app that Rachel talked about. And Brian was mostly handled turning it into this form. And so it made it really easy, really efficient out in the field. There wasn't any data entry involved, and I could easily download a shapefile with all of the information at the end of the summer. So again, great for me, but what does it have to do with all of you? And I can explain that real easily. Wyoming, it's no secret that Wyoming's big, almost over 62 million acres. And so that's way too much area for me to cover by myself, or even for the 10 of us who were working at it last summer to cover. So the fact that this protocol is an app makes it really easy for people to help, people like all of you. So now would be the time to take out your pen and paper, because I'm going to go through how you can get the app and how to use it. And I'll show you a map at the end of this for what we covered last summer, and it was pretty good for 10 people, but it could be a lot better. And I have another year to work on this project based on that constraint of 2 years for a master's degree. We'll see. So yeah, for any of you thinking, when can I start? The answer is today. No money down. This is the sales pitch portion of my presentation. So the Cheatgrass Rapid Assessment Protocol app, it really should be a form, but it's much more fun to say crap app. You can download the app at striderforms.com. If you scroll down on their website, there's a big red button that says download mobile app. And again, you can get it onto your smartphones or onto tablets. And then the next step is to contact Brian or myself for a username and password. Once you have it downloaded, the little symbol up in the corner is what it'll look like when it's on your phone or tablet. So you click on that to open the app, and this is the first page that you come to. And the first step is to load a new form. So again, you can get the different forms, like the monitoring form that Rachel talked about. But the form for my project is called the Cheatgrass Assessment. That's the one you want to choose. And I believe this is where you need to enter the username and password to download that form. And once you've done that, the adventure can begin. So you go out to a site that you want to survey and click on Fill Blank Form. And you go through some of this introductory information. You pick the form you want to fill out, in this case, Cheatgrass Assessment. You have some instructions, and then observer name, so just your name. You slide through, and the next step is this GeoPoint widget, and it comes up with a button that'll say record location. So you click on that, and it loads your location using the GPS on your phone. Once it gets down to an accuracy of about 5 meters or less, it'll automatically record the location. But if you're in an area where service isn't really good, you can always force it to record the location with the button there on the left. And once you have that down, you're ready to go. And the next step is taking a picture. So it's just like you would take a picture with your phone. Once you click that button, it launches the camera. And I usually try to take a picture, these are just some examples from last summer, that has a sliver of the horizon that is kind of angled so that you get some of what's close to you as well. Amanda Van Pelt helped me out a little bit this summer, a lot, and I liked her description, which just was, she worded it like you can imagine a giant Daubenmeier frame as being placed down over your head, and that's how you're trying to characterize the landscape for this app. So that's something to think about with taking the picture. And then the next page is all of your estimates. So percent cover for Cheatgrass. If you click on the Select One Answer button, you get the 5 different categories that you can choose from, and you have those same categories for percent cover of perennial grasses, shrub cover, and bare soil cover. And then Cheatgrass patch size. So you can read the instructions there. It's an estimate of the diameter of the cheatgrass patch. So if you click that, you get different categories based on the diameter, so 1 to 10 feet, all the way up to greater than 100 feet. And if you're not comfortable with those different categories, those measurements, there is an option for other and a little box where you can enter in your patch size. If you do choose a category for size, it doesn't restrict you from writing in that little box. So I've used it to make notes, such as that the infestation's along a road. So that's kind of nice. And then there's just one more step, which is that extra information I talked about. So dominant shrub, the list is longer than what's shown over there. And you can pick multiple if there's co-dominant species. And then other invasive grasses. So there's just really 4 options there. Bulbous bluegrass and Japanese brome are here in Wyoming and pretty prevalent in some areas. We did have to check those off this summer a couple times. Medusa head wild rye and ventonata grass are not in Wyoming right now, to my knowledge, and fingers crossed it'll stay that way. But they're just some other grasses to keep an eye out for. And then evidence of disturbance is just a yes or no, and that's pretty subjective, but it's there. So after that, you're finished with that location, and you'll get this nice little screen. You don't have to change the name of the form, and it automatically checks the box for finalized. So you just hit Save Form and Exit, and you're ready to go on to your next location. So it literally takes about 5 minutes to survey an area using the app, and again, you don't have to lug around your clipboard and your camera and your GPS. So it's really nice. And then the final step is sending the forms in so that I can access them. And it's just a matter of clicking on that button, selecting all of your cheatgrass assessment forms, and waiting a few minutes while it loads them, uploads them. So yeah, that's pretty much it. And then I guess how this could benefit you, I would be more than happy for anybody who helps to, if you want to request like a shapefile with the points that you collected or of points in your area, I would be happy to share those. And this is the map from this past summer. Like I said, I think there were about 10 of us collecting data using the app. And we were able to gather about 300, or survey about 360 points. And I don't know, it's probably really hard to see, but the red points are cheatgrass dominant and dark green are no cheatgrass. But you can see still quite a few gaps there. So again, any help would be appreciated. If anybody's interested, you can come and talk to me at any point to get my email during this conference. And this is just interesting to look at. It's just a combination of the data collected this summer and data gathered from different agencies this past spring. So some of the polygons are from Forest Service, Nature Conservancy, state lands, and then the big clusters of, they're actually clusters of points, were from Sam Cox, very large-scale aerial imagery that some very helpful students helped me process, or they really did all the processing for those. to kind of go through all the images and look for cheatgrass and put them into one of the 5 categories. Future steps for this project so that you know what you're contributing to if you decide to help. Summer 2014 surveys this next summer will probably try to be a little bit more targeted. I would like to focus in on some areas that we know have burned, just because of that relationship I talked about between cheatgrass and fire. I would expect to see some correlation there. And we want to target some areas that we know are cheatgrass dominated. So the histogram up there is just a breakdown of points collected this last summer, the 360 points, and where they fall for cheatgrass in terms of the 5% cover categories. And so you can see over 200 points were cheatgrass free, while fewer than 50 were cheatgrass dominated. So it would be really nice to have some more representation of areas that are cheatgrass dominated. And then visit some of those polygons collected at the workshops for gathering local expert knowledge. And having some more representation of areas that are cheatgrass dominated will help with the distribution model, which is something we're working on now, and there's still a lot of work to be done there. But I guess just to give you an idea, we have some tunes going on. The image in the bottom right corner is sort of what the output would look like. So it would be a probability surface, basically showing the probability of cheatgrass being there or not being there. But we're hoping to have something a little more detailed and look at cheatgrass free versus cheatgrass dominated, so that theoretically if you had a location where you knew that there was a trace infestation, you could use the model to kind of determine if that infestation was likely to take off and dominate the area versus if it was likely to maybe stay contained. So again, that's something that's still in the works. And then that final step, which hopefully I can get done next fall, is the prioritization model, where we'll look at overlap of high probability areas with critical wildlife habitat, and in order to find areas of high priority for management. And to finish up, sort of where I see this project fitting in the bigger picture, ideally it would be a phase 1 of three different phases. So it would just provide a starting point for a statewide cheatgrass management strategy. And then phase 2 would be site selection and implementation. So, you know, a group may be actually using this tool to determine highest priority areas within the state, and maybe trying to coordinate management efforts a little bit. And then Rachel talked about how important monitoring was. So just continuing to track changes in extent and severity over time, so that we could actually answer that question I brought up in the beginning of whether a large-scale effort would be effective. This project is definitely a group effort, so I have a lot of people to thank. My committee, the second bullet's funding. I mentioned Sam Cox provided a lot of aerial imagery, and Ken Henke donated a lot of the maps that we used for workshops last spring. The fourth bullet down is just everybody who's contributed data so far. Holly and Amy have been helping me out with the prediction model, or with the Nature Conservancy. And then everybody who helped out last summer in that last bullet. And again, you can all include your name in that list of distinguished crap app users, please. So thank you for listening, and I'd be happy to answer any questions.
One important point that Cara did not mention, I think,
okay, so for people on the webinar, the question was, when you try to download the forum, that's when it asks for the username and password. And I apologize, I wasn't sure how soon in the process that happened. But and so how do you get the username and password or set one up? And that's where you need to contact either Brian or myself, and we can help you get set up with one. So an email would be ideal. If you just talk to me here and now, there's a good chance I'll forget. So an email would be good, and we can send you a username and password and you can get started. Yes. Yeah, it's the same. It's Cara is the company that developed it, so it's the same as the one Rachel was talking about. As I mentioned, it's not really calling it the crap app, I guess, isn't really fair. It's really the crap form that goes along with Cara's app. Like I said, it's just more fun to say it that way. But yeah, it's not available, I guess, for Apple products yet.